Question number 5. We've been given a quadratic function f of x which is equal to 1 minus k times x squared plus x plus k, where x is a real number. And we need to find the value of k for which this function has two equal real roots. So to find the value of k, we need to use the discriminant of a quadratic which is equal to b squared minus 4ac. And you also need to know that if the discriminant of a quadratic, which is b squared minus 4ac, is less than 0, then the quadratic has no real roots or it has complex roots. And if the discriminant is equal to 0, then the quadratic function has two equal real roots. And if the discriminant is greater than 0, then the quadratic has two distinct real roots. So since we need this function to have two equal real roots, we'll equate the discriminant, which is b squared minus 4ac, to 0. So now let's write down the values of coefficients a, b and c. So a is the coefficient of x squared, which is 1 minus k. B is the coefficient of x, which is just 1. And c is the constant term, which is equal to k. So now let's plug in these values in the discriminant. So we have 1 squared minus 4 times a, which is 1 minus k, times c, which is k, and this is equal to 0. Now let's expand the brackets. So this will be 1 minus 4k plus 4k squared equal to 0. So now I'm going to rewrite this in the form 4k squared minus 4k plus 1 is equal to 0. Now to solve for the value of k, we can use factorization. We can factorize this by splitting the middle term. So we need two numbers that multiply to 4 and that add up to negative 4. So the numbers are negative 2. So negative 2 times negative 2 is equal to positive 4, and negative 2 plus negative 2 is equal to negative 4. So I can split the middle term and write this as 4k squared minus 2k minus 2k plus 1 is equal to 0. Now from the first two terms, I'm going to factorize 2k. So inside the bracket we will have 2k minus 1. And from the last two terms, I'm going to factorize negative 1. So inside the bracket we will have 2k minus 1, and this is equal to 0. So now I can take 2k minus 1 common from both these expressions. So this will be 2k minus 1 times 2k minus 1, and this is equal to 0. So 2k minus 1 multiplied by 2k minus 1 will equal 2k minus 1 whole squared is equal to 0. Now I can take the square root of both sides. So 2k minus 1 will equal 0. Now I can solve for k. So k will equal 1 upon 2. So this is the value of k for which this function has two equal real roots.